Today we're going to talk about first derivative test. The first derivative test is a method for determining whether an inflection point is a minimum, maximum, or neither. Inflection point is a point on a curve at which the curve changes from being concave, concave downward, to convex, concave upward, or vice versa. At the point of the curve where the curvature changes its sign while a tangent line exists.
First derivative test for a critical point. If the derivative is a negative on the left of the critical point and positive on the right, then the critical point is a minimum. If the derivative is positive on the left of the critical point and negative on the right, then the critical point is a maximum. In any other case, the critical point is neither a maximum nor a minimum.
Example: consider function 6x minus x squared, which has a derivative of 6 minus 2x. F has a critical number at x equals 3, since 3 is the solution to 6 minus 2x. To determine whether this critical number is a max, a minimum, or neither, consider where f is increasing and decreasing. As the diagram shows, x equals 3 is a maximum point.
Local extrema with first derivative test. All local maximums and minimums on a function's graph, called local extrema, occur at critical points of the function, where the derivative is 0 or undefined. Not all critical values are local extrema. Example: function equal 3x to the fifth power minus 20x cubed. First, find the first derivative using power rule. Second, set the derivative equals 0 and solve for the x to find critical values. Third, make first derivative test to determine whether peaks or values at those x values. Take a number line and put the critical values. Pick a value from each region, plug into first derivative, and note whether positive or negative.
In number line, mark each region with the appropriate positive or negative sign and indicate whether they are increasing or decreasing. Obtain the y values of the local extrema by plugging the x values into the original function. Next, we have an example. Function equals 3x to fifth power minus 20x to the third power. First, find the first derivative, then the result. You need to make it equal to 0 to find the critical values. Then you place those values in a number line, find a number between those intervals, and then those numbers plug into the first derivative function to determine whether they are increasing or decreasing. Then you will find a maximum and a minimum. And those two numbers, you need to plug them into the original function in order to get the y values, so you can get the maximum and the minimum points.